Hi everyone, my name is Kaushik and today I'm trying to solve the July previous LeetCode challenge problem. So in this previous week that was scheduled, so I was just solved that problem on that day, but I am not able to produce that video due to my illness. So right now I am trying to solve this problem. So let's focus on that. So basically there is a two number has been given, that is one is n and another is k. So we'll have to find that k inverse pair of array and number of k inverse pair basically. So for integer array norms, a inverse pair is basically that suppose the first part the from that any number which is the larger than the next upcoming integer, it is greater than that. So in that case that will be an a inverse pair combination. So basically we'll have to return the number of different arrays consist of number from 1 to n in such a exactly k inverse pair. So it could be a large number, so that's why basically it is given as a modulo function 10 to the power 9 plus 7 basically. So how I am trying to solve this problem, let's focus on that, and then after that I am trying to dry run, and then after that I am trying to implement my logic as a coding interpretation. So basically that is so basically what is that k inverse pair? So basically what is inverse pair? Suppose 1 2 3, so that is there is no inverse pair, so it could it can call as zero index pair. Suppose you are given as a multiple number, this is a long number, so 1 2 3 4 5 6 7 8 9, so but k is given as 0, so that is also a inverse pair of zero index pair. So that is why when k is 0 it will always return 1. It is always return 1, and when n is equals to 0 it is written 0 basically, because when n is 0 there is no element has been present in that array, that is not possible to make that the index pair, that is k index pair. So let's focus on that, the logic behind that, what is happening. So what is happening that suppose 1 2 3, the length is 3 suppose, so in that case k is equals to 1, in that case 1 then 3 and then 2, that is an k that is an 1 index pair, sorry not index k inverse pair, in 1 inverse pair. So and also maybe that k is equals to 1, and if the k is equals to 2 for that that purpose, so in that case maybe in that one that 3 up to 3 to 1, that is 3 to no, there isn't 3 for k3 in that case, because 3 1 also 3 2 and 2 1, so basically there is 3 inverse pair has been present there. So that is that for k3 basically, and for k2 is basically 1 that is 3 1 2, basically 3 and 2 and 3 and 1, so that is 1, and another is 2 3 1, maybe hold on, yes 3 1 and 2 1, yes that is the k2. So that is the basically that the index pair it is meant to be. So how I am trying to implement that one, so let's focus on that. Suppose n is equals to 3 and k is equals to 0, so I am trying to solve this problem, basically that the matrix orientation problem. So how I am trying to do 1 2 3, so 0 1 2 3 0 1 2 3. I am suppose k is equals to searching the k is equals to 3 basically. So from beginning of 0 to 3 we will have been discussing with each other. So first, what is that? 0. When 0 0, that is an also impossible k, and I am also previously said that when 0 has been given, so that is that one and that is bottom. So in k is 0, that is also possible, that 1 1 and 1, because k is 0, that is an only serial by procedure, and that the serial by value will be present, that is a 0 index pair. So that is why that is a solution is called as 1. So when 0 and 0, so what is happening? That is n is equals to 0 and k is equals to 1. That is not possible. So 0 0 0. So all are 0. So 1. So the number is 1. The number is 1, and the one value has been present and k is equals to 1. That is not possible, because so one number that is not been possible, so that is the 0. So after that 0 and 0, so after that 2, so 1 and 2, so I need an 1 index pair, so that is possible, that is 2 1 1, so that is 1. And for 2 and 2, that is not possible, so 0 and 0. So 3, for 3 case, that is 1. For 1 3, okay, no sorry, 1 3 2, that is 1. Yep, that one. And for 2, so what is that? 1 3 1 2, because 3 is paired with 1, 3 is paired with 2, so that is 1 1. And 3, no, hold on, 1 3 2. Yep, no, 1 3 2, that is for 1, and another has been present, hold on. So 2 1 2 1 3, maybe, hold on. 2 1 is mapped with 1 and 2 is 3, no, hold on. So 1 2 3, and this make 2 k is equals to 3 is basically what is happening. 1 is the 3 1 2, when k is equals to, that is basically 3 1 2, and another is 2 3 1 2 1 and 3 1, yes, that one. So that is updated to 2, and 3 and 3 and 3, that is not yep, hold on, 3 and 3, that is not possible, because hold on, that is not possible, I'm not sure. 3 2 1 3 2 3 1 and 2 1, yes, that is for one case. So that is how that is happening. So there is I found an observation there. So that is basically from I minus 1, that is the initial condition, that's the value will be updating with there, that's the j value. So that is 1, all the value has been previous one, that is same, so that one. So what is happening, that is the portion for for that for 1, that is came to here, from 1 that is came to here, and from 1 and 1, that's the value has been came there, there is 1, that is 1, and from 1 and 1, that sum is goes to there, that goes to there. until the n is not equals to the, I mean that until the n, I mean that the, if I've been taking that as an I, if I is less than or equals to the j, if I is less than or equals to the sum is taking as an that one. So if I've been taking that also, next one, that will be 1. And another case you saw that when there is a same value has been present there, and that value will be deducting from here, because that the 3 of 3, that means that 3 of 3. So when that is same, I and j has been same, I and j and is becoming the same. So in that case the j value will be deducting from I. So 3 minus I, that means 3. So it is 0. So what is the 0th value? That is 1. So that will be deducting. So that is 2 minus 1, that is 1. That is equals to 1. So that is why that is the value will be deducting from here. So let me another example for n is equals to 5 and k is equals to 3. Make that observation carefully. Zero, 1, 2, 3, 4, 5, 0, 1, 2, 3. Yeah. So first the value is 1. So 0 and 1, the m goes to there. So when j value has been greater than that, so then j minus I is greater than 0. So j 1 minus 0 is basically 1. 1 minus 0 is basically that one is value is updating there. 1 minus 0 and 0, that is that one, and that the value has become all are 0 because not possible there without any value. And for 0 and for 1 and 0, for one case the value is 1. That is 1. For one case that is 1. And for 1 and 1, what the value? 1 minus 1, that is 0. So what the value has been present? That the value has been present. So 1 minus 1, 0. So after that all the value has been become 0. So 2 minus 1, that is 0. So 0 minus 0, 0. 3 minus 1, 0. So 0 minus 0, 0. So basically what is happening that so 2 minus so first of all we'll have to take that. So 1 and 2. So 1 and 2, what is happening? That is 0 is then basically that is possible that the value will be I minus 1. So I previously said that if the 0 is given, that is always one value has been initialized, because that for 0 that is all the sorted and there is a 0 inverse pair. So for 1 and 2, so 1 minus 2, that is a negative, and for number of 2 and integers, there is an one index one inverse pair, so that is 1. So what is happening that is goes to 0 and 1, 1 and 2. For 2 minus 1, so what is happening that? So for 2 case, so that is j minus I, that is 2 minus 2, that is 0. It is greater than or equal to 0, and for 2 at least one more greater number has been present in the array to make that index value. That means that if we need 2 inverse pair, so we need at least 3 integer. So that is why when that is come there, that will be deducting. I am trying to deducting this. So 2 minus 2, that is 0. So 0 and 0, what is the value? That is 1. Right now that is the value is 1. So 1 minus 1, that is 0. So 3 minus 2, what is the value has been present? 3 minus 2, basically what is that? 3 minus 2 is basically the value will be there. For there, that will be the value will be for hold on, 2 minus 1, basically the value will be that I minus j, that one, that the value has been came there, and then after that for I 1 minus 2, basically that j is not possible, so I minus 1 j, so I minus 1, so that is also one case. So 1 plus 1, that is 0, so that is 1. So then after that, what the value has been come there? So that is 0. So after that, so j is 3 minus 2, that is 1. So 1, it is greater. So dp of I minus 1, what is that? dp of I minus 1, right now the value is 0. So from there, so that's the 0 value. So 0 value is, so that's why that is updated to 0. So from 3, so initially that is 1, and for one case, that t is basically that is for 1, and dp of I minus 1, that is 1 of 1, that is 2, and then after that 3 of 2, what is that? So I minus 1, that, so that is 3. Hold on, I have in previous logic what will happening, that basically my logic is that dp of I minus 1 j, and if the j minus I is greater than or equals to 0, in that case I will deducting that value dp of I minus 1 of j minus 1. So what is happening that? 3 of minus 1, so 1 minus 3, that is not 1 minus 3, that is not a negative. So in that case, so dp of I minus 1 j, so basically 1, then 2. So 2 minus 3, that is not possible. So dp of, that is 2. So after that 3 and 3, that is 0. So 0, that is 1. So what is that? That is the 2 value has been present right now. And from 2, so j minus I, what is that? 0. 3 minus 3, that is 0. So what the value has been present? Previous one, that is 1. So 1 minus 2 minus 1, that is 1 there. So 4 from previous one, 1, and 1 and 4, that is not in greater than 0. So that is why, so what the previous one, that is 3. So after that, what is happening? That 3 and 2, 3 and 2, 5. So j minus I, basically what is that? 3 minus 4, that is not. So 5 and 6, 6. So what is happening? The first of all 1. So then after that 1 and 1 minus 5, is it greater than 0? No. So 3 and 5, 8. 3 and 1, that is 4. So after that 2 minus 5, so okay, no problem. So 4, 5, that is 9. So 6 and 9, that is 15. So that is the 15 k index inverse pair present there. So that is that's the how the way I am trying to implement my logic. So basically the time complexity is n plus 1 I am taking there, and the k times, and the k in this basically not n, there is a n into k is the time complexity, as well as that I am taking that extra space of n into k. So the space complexity also order of nk. So right now I am trying to implement my logic. What is happening there? So first of all, I make that value integer dp of I'm taking as a constant value basically first. That is easy to make. First of all, memset dp of -1, not -1, 0, and size of dp, and then return solve n comma k. So make that I'm trying to make the function with integer n and integer k. So I'll have to initialize the dp of 0 is equals to 1 at the first time, and for there is basically what is happening. For integer I is equals to 1, I less than is equals to n, I plus plus, integer value is equals to 0, long. We'll have to take that long because it said that the reason the value will be become great. So for integer j is equals to 0, j less than or equals to k, j plus plus, and for after that val will be dp of I minus 1 j, and if j minus I is greater than or equals to 0, in that case I will deduct that value from that variable. That means that dp of I minus 1 j minus I, and after that I will insert that value into the dp array. So dp of I, that is val modulo mod. So we'll have to initialize that mod first. Has defined mod 1 3 6 7 8, that one. So I'll have to return that value. After that return dp of n of k. So let me check that if I am right or wrong. Yeah, it's coming right here. So let try to submit there. Is it right or wrong? Check there. Yeah, it's got accepted. Thank you so much.